Okay, we are now in the changing world, as you said, and the mining industry is looking more and more for new solutions, and mainly because of the change we have in this context. And you saw the fuel concern, how the fuel is important in the mining sector, and also the concern about the grid connection in South Africa regarding the ESCOM limitation for production. These are, let's say, two main problems that have to be solved for the future, including the emission problem and CO2, and for sure all which is regard to logistic. Logistic is also not so important here in this country, but we can find that in all the remote areas in which we can find off-grid system or even more complex area and countries where the safety requests are not fulfilled. Yeah. Then logistic is always a big problem, and it's linked with the operation cost and the fuel cost. Okay, we have been in this recent past looking for a lot of generation cost variations. On one side, the renewables are going down. We saw that in South Africa for this from this first round of now to the fourth round. The difference of cost of electricity being produced by renewable, but this is also the same in all the countries in the world. And on the same side, increase of oil, even if we saw that recently that we can have a drop down of the cost of oil. But I think that now the let's say competitive of renewable is no more a future. It's today. It's even yesterday in some case, and mainly when we focus on the area where the fuel concern is very high, where the fuel is very expensive because of transport, because of logistic. Then we are already with a very interesting solutions. It's why grid connection is one thing, and hybrid case, it's another topic. Hybrid case, we will see what's exactly an hybrid solution. This is typically what we have in an industrial plant, and industrial load or residential load can be a city, can be an industry, and then mainly provided by diesel genset in general. This is one of the most common way of producing energy in the world. And then automatically, when we want to introduce some existing resource or local resource, we are always dealing with sun or wind or biomass or any other, or hydro, but any other system that are local, in which you do not require to transport any fuel. That's sure that in order to make that system work, it's not just to build a PV plant, or it's not just to build a wind farm or a storage system. You need also a control system. This control system is, let's say, the brain of the whole hybrid. And without this control system, that makes quite difficult to manage all these renewable sources, just because you know that the volatility of this source are quite high, depending on the areas. We are talking about the penetration, and this is highly linked with operation cost. We will see that later. And what in terms of penetration, there is a lot of things that have already been written, including there are some regulation in the world that limits the penetration to a certain amount. Just mentioned the French regulation that limits this penetration at 30%, which means that if you exceed 30% of the renewable in a certain moment in the grid operator has the right to shave and to take some plants out of the grid, out of the production. 30% is quite low. we consider that we can make much higher penetration in a grid. And with higher penetration, you get more renewable energy, and automatically you save more money and more fuels. Then if we just look at what can be achieved in terms of this kind of penetration, from right to left, from left to right, we are going from the low penetration to the high penetration. Low penetration is just what utilities are doing now in all the countries. Grid is absolutely infinite, and you can put any megawatt of renewable on the project, on the grid. There is nothing that will happen. You will not get any variation of frequency, voltage, and you will not affect the spinning reserve of the grid. If you go for a larger integration, then you will request either a forecasting system, just to have a prevision of what will happen in the next hours, next minutes, next days, and you will, if you go for even larger penetration, then you will have to jump for some stabilization with battery system or something like that. Then you have three kinds of solution. These three kinds of solution can bring different advantages. Just very simple calculation. If you are just on the right side, on the left side, sorry, you are in low penetration. You have 8,000 hours production, normal production per year. PV plant can produce maximum 1,500. Then you can see that from this 8,000 to 1,500, it's a small amount. And then you cannot think that you will introduce more than this 5 to 10% of renewable inside of a grid, which is quite small. And okay, it's even if it is interesting that it's okay. As far as something has to be done, it's always better to try to be on the optimum of the solution. If you look at the left, at the right side, high penetration, you can see that we can go much more than 100% of renewable at a certain moment, either in wind or in solar, and automatically you will shave and you will have a curtailment of the production. But even with this curtailment, you can still achieve a quite good return on investment. Okay, just at OPEX, in general, you have to define a strategy. And the OPEX cost, you basically define when you invest, when you are starting your CAPEX, either for a brownfield or greenfield project. You have already installed a system, or you will install or implement a new system. You have to define what's the strategy, and the strategy has to solve a problem, an existing problem. If you have no problem, okay, most probably you will not be very accurate on the results. Then you need to have one problem. The problem can be the cost, can be the stability of the grid, can be the reliability of the system. You can have a lot of reason to make that CAPEX existing. But anyway, when you decide, it's a problem of OPEX, because building a plant is very funny. We can do that easily. We are not alone to do that, but which is much more fun is to operate, because this is a real world. It's not just building and then, okay, now it's gone. Then OPEX is a very, very important thing in the project, and I would say that's a key decision factor. And this, for sure, you have, when you want to go for OPEX saving, you have direct savings, which are directly linked to the comparison between the existing and the new solution, which is mainly liter of fuel, hours of genset production or maintenance costs. These costs are directly linked to the number of hours of genset production. And then you have obviously some indirect costs, and these indirect costs they are not automatically counted inside of the project, but they have to be, and it's logistics, storage, and so on. And there are two additional factors that also has to be taken into account in that kind of analysis is how much reliability I want to increase, I want to add in the system in order to get in more safer. For example, how can I, at the moment that I'm changing a system, I will always ask to have a new system which is more reliable or safer than the former one. This is also one key decision factor. You cannot bring a solution that will introduce instability. Then automatically it's also reviewing of the complete system that need to be performed at that time in order to be sure that the new system will not perturb the existing one. Other things which is very interesting in terms of OPEX saving, it's how can I reprogram my operation, my day-night operation, in order to fit with existing renewable production. Then you have to know what about your curve, your load curve for sure, but you have also to know what are the existing renewable sources and when they will be existing or not existing. And that's if, for example, we take an example of a cement factory. Cement factory, they have two processes, electrical process and a thermal process. For sure, thermal process, you need to keep it always. And then you can manage with the mechanical process for the crushers and all of that. And maybe put that specific consumption in regards of the existing production of renewable. And then you can manage that kind of load. That's the same, for example, if you have water production. It's not necessary to produce water all the day, but you can shift water production from night to the day. Same if you have a waste plant, you can translate the waste plant producing energy from day to night just to avoid storing energy. Okay. I would like to just to put that as an example, one specific case in which we have been working some weeks ago. That it's not in South Africa. It's a Western African country, which is a mine. It's a gold mine in this case, in which we have been working on a project which is completely off-grid, very high cost of fuel. You can see $1.6 per liter, which is tremendously high. This is including the transport and the storage. And this is obviously the perfect case to introduce renewable, just because any kilowatt hour that you will produce with renewable will be at around, let's say, 10 to 15 cents. And if you compare to the existing production, that should be around 50 to 60 cents. Then you have in this case a very large range of productivity to be explored. Then that's in general that's the base case that has to be developed. In our case, we have several solutions that can be handled. This is the standard one. Then we have a 10 megawatt load, more or less 11 megawatt load, 13 megawatt peak load, quite stable. We have today nine generators. There are one solution which is we consider as low to medium penetration, which is small PV plant. In this case, just a PV plant, maybe a control system a little bit more stronger, a forecasting system, and that can be a system that can be working. And we have another solution, which is much higher PV integration. We are talking here about more than the capacity of the mine, much more, 140% of the average load. In this case, absolutely sure that we will require something that stabilized the production during the day, which means we will need some battery system. That's more or less the simulation with a medium penetration. You can see here some then everything which is produced is being transferred to the local grid. You can see in black the diesel curve, and in blue the load curve. Then anything produced is being consumed. For the high penetration, it's a little bit different. You can see in red storage of the battery, and you can see in green the energy coming from the sun. In most of the case, we have more energy than request. And then you can see in black here that starting from this point, we can lower the curve of the load of the diesel up to a very small amount, just giving the security for the spinning reserve. Okay, there are also some bad days. In these bad days, okay, either you have a problem of load, then okay, in this case we store, but we are losing part of the energy, or we have, let's say, very bad weather, and then we are in the first case. All of that, just one single solution is very difficult to highlight and to find the best one. Then at the end, what you need to perform is complete several, in this case, we perform more than 30 solutions with different, here we have several kind of batteries, and here several kind of PV plants. And from all of that, we decide, okay, this one seems to be the best one. It's not this one or this one, then okay. As far as we can, as the input information, the load curve is correct, we can define what's the optimum side. And then for all this solution, PV curtailment, fuel-based generation, and then all the parameters of the plant can be recalculated. Also, if in this case it's a pure investment from the mine, but that's also very easy to build a business plan based on a PPA basis and what's on. In this case, we have return of investment, which is very short because the oil is very expensive. Then we are talking of something around 3 to 4 years return on investment, and that's very, very interesting project. Just this is to illustrate what the effect of each single key KPI. If we are moving the capex of some percent, what's the influence in the savings, and same for the payback or LCOE. We can see very easily that the LCOE is not changing a lot when the capex is changing. It's much more depending on the fuel, the cost of the fuel, and then okay, if you look at the cumulated savings, that's the same. That's not changing so much. For 10% increase, you have less than 10% decrease. Yeah, payback time is very sensitive. Yeah, both for fuel and for fuel and capex. Then these are the, let's say, the studies that has to be performed just to find what's the right solution. It can be that the right solution is not the one that will give the shortest payback, or will give the lowest COE, or each project has its own problem to solve and its own strategy. Okay. Oops, sorry. Yes. This is more or less what I said. We have, in fact, in this world, 4 kind of model. This left one here, which is a pure utility model. You are grid connected. Everything that you produce will be given to the grid. It's a take and pay system, and that's a feed-in tariff system. In any other operation, then you are either solving a weak grid system problem, you are solving a off-grid system, or you are on-grid, but you need some forecasting because the grid is too volatile. In each of these one, you need some specific guarantees because you are never sure that you will produce all the energy on this grid. Then, what we intend to do, or what we are doing, is that risk is a key subject in project development, and the aim of this technology is always to decrease the risk for the customers. It's not to increase the risk. And then if we scan the potential guarantees that can be given for such project, you have several kind of guarantees, and then you can go from a pure performance ratio guarantee from typical PV system up to a guarantee in liter of saving, or even in kilowatt hour, or even in pure money, in dollars or in euro. Okay. Then, in fact, depending on what risk you want to cover, then you will have several kind of solution. Obviously, this is not the same from the same kind of guarantee from this beginning, which is just a transformation guarantee up to a production guarantee. Okay, we consider that introducing renewable in such grid makes absolutely sense, just because we can, at the moment that we introduce that system, increase the reliability of the system. We can also increase the view and the prevision and the reliability of the costs, because this is very important for your forecasting. And then automatically lower the footprint in carbon footprint. All of that supported by reliable contractors that are bankable, and then automatically that can bring with you some guarantees and some project development. That's okay. Thank you. If you have some questions.